This is part 3 of our lesson and notes for Unit 2, Day 8, inequality statements with absolute values. So we've just talked about how we can look at a statement, and if the absolute value information is less than a number, then we think less than, and it's going to be an and statement. It means that we are going to have some section on our number line that all of our values are supposed to equal. And of course, if our absolute value information is greater than a number, then it could be going in opposite directions on the number line. So we're going to look at some examples down here. Number 1, I have absolute value of x minus 3 is less than 2, And so I already have my absolute value isolated. I always have to isolate and split, right? So I'm going to isolate. X minus 3 is isolated already, and now I'm going to split. With inequalities, I will split. I just take away my absolute value bars and keep everything the same the first time. The second thing, I'm going to say x minus 3, but here's where things change. I need to say that this is greater than negative 2. Okay, I'm flipping my sign and I'm changing the positive or negative of my constant. All right, so x minus 3 is less than 2. I'm just going to solve that. I'll add 3 to each side. I now have x is less than 5. Over here, I'm going to add 3 to each side, and so I have x is greater than negative 2 plus 3 is just 1. Okay, this is an absolute value is less than 2, so I know I'm going to have an and statement. With an and statement, normally that means I can condense. I can write this in a more efficient way. So I'm actually going to think, look, I'm in between 1 and 5 on my number line. Okay, x has to be greater than 1, which means 1 has to be less than x, right? And also x has to be less than 5. So here's my same x is going to be less than 5. These two pieces of information, x is less than 5 and x is greater than 1, they can be written in a more condensed form like that. All right, so I know that my barriers are, my endpoints are 1 and 5. So I'm going to make sure I have 1, 2, 3, 4, 5 on a number line like that. And so I'm going to say 1 has to be less than x. It's an open circle because it can't actually equal x. So I'm going to be bigger than 1, and also x has to be less than 5. X to be less than 5. And since it's an and statement, I want all of these things in between. As long as my x value falls somewhere on that solid line, it means it is a true possible value. So I could choose 4, because that's on my line here, and plug it in. 4 minus 3 is 1, and the absolute value of 1 is 1, and 1 is less than 2, so that works. Right here, I have a fraction involved with an absolute value. Do not distribute. These are prison bars. You cannot get in or out, so we are not distributing. Instead, we need to isolate that absolute value bar. We're going to multiply by 2. Okay, I'm multiplying by the denominator to get rid of that fraction. It's a positive 2. I'm going to multiply 2 times 1/2. That gives me just 1. So I have the absolute value of 8 plus x. I multiplied 2 on the left side, so I have to multiply 2 on the right side. Okay, I'm going to say that's less than or equal to 6. I don't change the sign or anything because I just multiplied by a positive number. All right, so now I'm going to split. I've isolated and I'm going to split. Everything stays the same the first time. 8 plus x is less than or equal to 6. The second time, 8 plus x is going to be greater than or equal to negative 6. And then we just solve. Subtract 8 from each side, x is less than or equal to negative 2. Subtract 8 from each side, x is greater than or equal to negative 14. Okay, my endpoints are negative 2 and negative 14, so if I need to put these on a number line, I'm going to say negative 14. Oof, got to make sure I don't miss anything here. Okay, 2, 4, some negative there. 2, 4, 6, 8, 10, 12, 14. I think I got that all correct on there. We're going to squeeze that 0 over here on the right. This is my number line. My endpoints are negative 2 and negative 14. X is going to be greater than or equal to negative 14. So I'm going in this direction. X is going to be less than or equal to negative 2. Here's negative 2. I want to be less than or equal to negative 2. And it's everything in between. I have a solid line here. So all of the numbers in between should be true. Let's just pick one. Let's just choose negative 8. Okay, if x equals negative 8, and I plug that into my original equation, it's going to look like this. I'm just putting negative 8 in for x, less than or equal to 3. I'm checking to see if this is true. I have to follow order of operations. 8 minus 8 is 0, less than or equal to 3. 0 is less than or equal to 3, so check, that worked. Okay. All right, here again, I cannot distribute, right? The safest thing here to do is to add 8 to each side. Okay, I'm going to add 8 to each side, but I'm going to pause for a moment. If you look and think, oh, I'm going to divide everything by 4, that's fine, but you have to divide every term by 4 if you do that. I'm not going to do that. I'm actually going to add 8 to each side. And so I have 4 times the absolute value of 3x plus 8 is less than 20. And now I can't distribute, right, because there's bars, so I'm going to divide by 4. I have 3x plus 8 in absolute value is less than 5. I have isolated, and now I'm going to split. Okay, the first time I have 3x plus 8 is less than 5. And the second time I have 3x plus 8 is switch the sign, switch the sign. Okay, switch the sign, switch the sign. All right. And 3x is less than 5 minus 8 is negative 3. Here I'm going to divide each side by positive 3. I'm dividing by a positive number, and so this is going to be x is less than negative 1. That's one part. Over here, I'm subtracting 8 from each side, so I have 3x is greater than negative 13, and x is, I'm still dividing by a positive number, so x is going to be greater than negative 13 thirds. I'm dividing 3 into each side, negative 13 thirds. I divided by a positive number, so I did not change the direction of my sign. If I want to put that on a number line, I'm going to have negative 13 thirds, which is kind of like negative 4-ish. That's going to be one endpoint, and the other endpoint is going to be negative 1. So I'm not doing my little hashtags in between. X has to be greater than the negative 13 over 3, and it has to be less than negative 1. So it is these numbers in between. And sure enough, once I had isolated my absolute value, I had less than, and I think about less than, and so I get my and section in there. And sorry for my strange lighting from my window. We're going to do a couple more examples. These, once I isolate my absolute value, it's going to be greater than some number. And so you have an example that you can look at on your notes. Now I'm going to come down here and solve these. We always want to isolate and then split, and then we're going to switch the sign, switch the sign. So I'm isolated already. My first my first inequality statement is going to be x plus 2 is greater than 1. My other is going to be x plus 2, switch my sign, switch my sign, so it's going to be less than negative 1. I'll subtract 2 from each side, x is greater than negative 1. I'll subtract 2 from each side, x is less than negative 3. All right, and so this is going to be greater than, I'm going to have an or, which usually means I'm going in 2 different directions. So if this is my number line, my endpoints are negative 3, negative 1, right? So I need x to be less than negative 3. It's going to be going in that direction. And I need x to be greater than negative 1. It's going in that direction. One or the other will work. If you have to write this with interval notation, remember I'm going all the way to negative infinity. That's the smallest I can be here. So I'm going to be from negative infinity all the way to negative 3. We can't ever reach the infinities, so we get a parenthesis. And here this is not equal to negative 3, it's just less than negative 3, so that gets a parenthesis as well. My endpoint here is -1. I go all the way from -1 to infinity. And again, I can't really be -1, so that's open parenthesis, and then infinity is going to be open parenthesis. Okay, all of the things less than -3 or all of the things greater than -1 will be true if we plug them into our original equation. I'm sorry, our original inequality statement. Okay, this absolute value is already separated. Nope, it's not quite isolated, just kidding. I'm going to add 6 to each side, so now I'm isolated. 3x minus 4 is greater than or equal to 8. We're going to split. Now we've isolated, we're going to split. Keep everything the same except for get rid of those prison bars. On the other side, we're going to have 3x minus 4, switch and switch. Switch my direction, switch my sign. Okay, add 4 to each side. 3x is greater than or equal to 12. Divide each side by 3. X is greater than or equal to 4. Okay, when I isolated, I'm greater than, so it's going to be an or statement. Over here, I'm going to add 4 to each side. 3x is less than or equal to -4. X is less than or equal to -4/3. I did not have to change the sign because I only divided by +3. My endpoints are -4/3 and 4. Okay, so I want x to be less than or equal to -4/3, so I have a solid circle and I'm getting smaller, or x can be greater than or equal to 4. Okay, so only the things smaller than -4/3 and greater than 4. If I write this as an interval notation, I'm going from -infinity all the way to -4/3. This is a square bracket because I can include -4/3. I can include 4 all the way to +infinity. I get a square bracket and a parenthesis. Square bracket. Okay, this is almost isolated. We'll add 4 to each side. Absolute value of 2x plus 1 is greater than 7. Now I split. So I have 2x plus 1 is greater than 7. And I say 2x plus 1, switch and switch. Okay, I'll subtract 1 from each side. 2x is greater than 6. X is greater than 3. I'll subtract 1 from each side. 2x is less than -8. X is less than -4. Okay, I isolated and I was greater than, so it's going to be an or statement. So my smallest is -4 and my biggest is 3. X has to be less than -4, so it's going that direction. Or x can be greater than 3, going in that direction. Interval notation, I'm going from -infinity to -4. I have open parentheses because I can't actually equal -4. I'm going here from 3 to +infinity. Okay, so pause the video, try the remaining problems on your own, and check your answers. I'm just going to write the answers for each of these. I'm not going to work it out verbally. So good luck, and feel free to email me if you have questions. The answer to number 1 is, oops, that's supposed to say infinity, not -8. The answer to number 1 is going to be anything from -infinity all the way to -3. I use a square bracket because I can include -3, or it can be from 6 all the way to +infinity. Let me make that look better. Okay, so when we have an or statement, we want the union of anything that can solve this part and anything that can solve this part. We want the union of those two pieces of information. That's what or means. Okay. All right. Pause and complete number 2. With number 2, once you solve, you'll end up with x is greater than 8 or x is less than -2. That's what it looks like on our number line. And we write interval notation like that. Okay, pause and work on number 3. I'm gonna start doing this video partway through solving this problem. I need to isolate, so the first thing I did was subtract 4 from each side. That left me with -2 times the absolute value of x plus 3 is less than -2. So now I'm going to divide each side by -2. When we divide each side by a negative, we have to change the direction of the sign. Okay, that's what I'm going to do before I even do the math. And now I have absolute value of x plus 3 is greater than 1. Now I will split x plus 3 is greater than 1, or x plus 3 is less than negative 1. Okay, I isolated, and my absolute value, once it's isolated, is greater than 1, so I know it's an or statement. Okay, subtract 3 from each side, x is greater than negative 2. Subtract 3 from each side, x is less than negative 4. So my endpoints are going to be negative 4, negative 2, right? X needs to be greater than negative 2. X needs to be less than negative 4. Either way will work. So I'm going from negative infinity to negative 4, and I'm going from negative 2 to positive infinity. Okay, pause and work on number 4. Oops, you can't quite see my answer there. Did you remember that if you divide each side by a negative number, you have to change the direction of your sign? Make sure you switched your sign. Okay, we end up with negative 3 halves as one endpoint and 4 as the other. If you switched your signs, you're going to see that you have to be the combination, anything that is true for both of them. Also, once we isolated our absolute value bar, isolated our absolute value section, that is less than 11, and so we know less than gives us and so we expected it to be an and. All right, here we're going to subtract 13 from each side first. So take a look at what happens. There's your little hint. And check your work after you're done. Pause the video now. All right, so I subtracted 13 from each side, and I got some absolute value thing. Has to be less than or equal to negative 4. There is no way for that to be true. I cannot possibly make something inside there and then take the absolute value of it and have the absolute value be less than 4. And so I'm going to stop right here, and I'm going to say there is no solution. There's no way for me to get any value that I'm going to take the absolute value of and have it be negative. All right, there are some extra resources in the extra resources folder in Schoology, and some of them are online, so you can certainly continue to practice your absolute value problems or any of the problems from this unit, and you also will have homework in Math Space that is due next class.